We have one of our correspondents, actually, who absolutely gets the prize for the furthest distance traveled today, environmentally, of course. But Farron Tiran used his skills as a storyteller to capture an actual citizen science experiment where he ran swimming trials with an invasive species of snake in his home country of Guam to see if they might have the ability to travel by water from island to island. Let's take a quick look.
Over 8 feet long, this guy, and really heavy, swam for a valiant hour and 13 minutes. Biggest snake so far, and that's the third longest swim we've seen in a snake. This is a brown tree snake. They're crafty creatures that are active at night and live and hunt in trees. The U.S. Department of Agriculture estimates they outnumber people 10 to 1 on Guam, with as many as 2 million of them on island. And these snakes have wrought all kinds of ecological and economic damage.
Oh my goodness. Farron, okay, first of all, why? Like, I have so many questions, but stand up for a little bit so people can see you. Yeah. Woo. So exactly what was your initial thought on this experiment?
We have a small island about 1.5 miles away from Guam proper, and it's kind of a de facto unofficial bird sanctuary. We released some surviving species of a ground-dwelling bird there because it was snake-free at the time, and then we found out it wasn't, and we're wondering how snakes got there. The prevailing hypothesis is they hitched a ride on boats.
Okay.
And someone on my social media suggested maybe they swam there, and I'm like, hey, that's testable. I'm in the water half the week anyway, might as well just do it. And put a call out on social media, and people just were messaging me like, hey, I got snakes for you, and
That is not a call I would ever put out on social media. But I love it. Thank you. So please, first of all, go check out his story, and then go find him and talk about snakes and all of that really interesting stuff. So Farron, thank you. We know that citizen science engages the public. And when transformed into a story, it has the ability to inspire even more lines of inquiry. Communicating science accurately and in an engaging way is something that our next moderator and panelists know a lot about. Turn it over to my colleague, Darcy. I think so. There he is.
Thank you.
Thank you.
Hello, everyone. Oh, that sounds somewhat good. Let's get a little bit more lively, though. I'm really curious. Who here, and stand if you're willing, who here studies science or studied past tense science? Stand. Okay. Or arms? Yes. Yes. Okay. Arms or bodies down. Who is intimidated by science? Perhaps some of you who study science are intimidated by science, because that happens. Now, who here is inspired by story? I think we have a way in then. All right, so I would like to have some other fellow science communicators join the stage to tell us how they approach these audiences that are divided in opinions and ideas and are trying to figure out what is exactly meant when someone says this is uncertain. And so let's get some ideas of their practice, and perhaps this will help you in thinking about your own storytelling. So I'd like to welcome to the stage Gabbi Ewing, who is a director of programming at PBS and part of PBS Digital Studios. Gabbi, welcome. Then we have Tom Liberto, who is a climate scientist, communicator, improv actor, and until last week worked at NOAA, where he was fired again. And then we have Kasha Patel, who is a science writer at the Washington Post. And that brings two trained in planetary science and chemistry to the stage. So fantastic. I feel at home. Everyone, thank you. So I'd like to, for our first question, ask, when I think about science communications, I always think audiences first. And so when we think about an audience that has emotions running through it, divided ideas, et cetera, that's something I really need to take into account. And I'm curious for all of you. So if you could give one or two sentences perhaps on how you approach a divided emotional audience. And we were chatting about this before, and Tom, you mentioned being relentlessly civil. What tell us about that?
Yeah, so I previously was the climate scientist at climate.gov, and I ran their social media, so part of my job was literally to deal with the Facebook comment sections of a government climate website. And I always give people the benefit of the doubt the first time, and I'm just relentlessly civil. Even if someone gives me the most sarcastic, ridiculous, leading sort of comment, I will take it on its face, and I'll say, hey, thanks for the comment, and then give them an answer about why they're wrong, whatever it is. And the way I look at it is I'm trying to emulate this sort of response, not only to, I don't have an idea what I'm going to convince that person to change their mind, but what I can do is help model the sort of arguments and behavior that other people can do who are reading that comment and take it back to wherever they may be. And also, because I know nothing pisses off somebody who's trying to get an emotional reaction than being relentlessly civil. So the back of my head, I like to think that person just started like punching a wall as I was just being very, very nice to them.
That's, thank you. Thank you for that, Tom. So Gabbi, when we were chatting, PBS Digital Studios draws a variety of storytellers from a variety of environments and places and that sort of thing. And you spoke to the importance of being authentic.
Yeah.
Tell us about that.
Absolutely. So we did some really interesting studies about audience segmentation, and regardless of whether they are firm, committed believers in climate change or on the fence or somewhere else in that range, being authentic is important to all of these audiences. And so that's what we really try to bring to the table. No matter, like you said, Tom, I don't know if I'm going to make them believe, but if they're watching and if they're being exposed to it and they can relate to the content in some sort of way, it's in their neighborhood, perhaps we're partnering with a local PBS member station, being authentic is really the most important part in terms of who we're putting on screen, being really transparent with our sourcing, with our transcripts, everything like that, linking to more sources, and yeah, responding to those comments. It's one is a conversation, another comment response is an argument, is our rule. So definitely being authentic is the most important thing, I would say.
That's great. And I will say, if you haven't watched any PBS Digital Studio shows, do. It's my favorite rabbit hole. So Kasha, so you're a science writer. You're also a stand-up comic. So how do you think about audience and tapping into emotions, or perhaps their divided ideas among them?
Yeah, they're actually a little more similar than you might think. I do specifically science-themed stand-up comedy. And I think for both of those, you have to make it personal. You know, at the Washington Post, we have a lot of analytics about our articles and like what headlines get clicked on and which ones don't, and you do headline testing. And you know, a few years ago, it used to be that climate change made this flooding event, this disaster, X times worse, and those would get clicks. And then as time goes on, people became less prone to click on those things. So you kind of have to figure out, oh, what are people going to respond to? When I say make it personal, I mean, it doesn't necessarily have to be like climate change did this. You describe the events that happen. Like if you're a farmer and you say, okay, it was really dry this season, I mean, you can explain how climate change did that in a more descriptive way and making it personal to why they are affected. And it's the same thing with my stand-up. If I go up there on a Friday night at like 10 p.m. and be like, hey, let's talk about climate change, it's not going to work. But if I can kind of like sneak it in there and talk about an event or talk about like my family member who is struggling with something, and then slip in something about the weather or climate, it becomes a little more successful, because then you're not like, it doesn't come off as like patronizing or like you should be doing this, kind of like wagging your finger.
That's great. That's also an excellent segue. So, in thinking about uncertainty and climate, and there's so many topics, which is both good and bad, that we could speak to. But let's maybe focus on thinking about water and thinking of like Farhan's excellent video about citizen science and those aspects. So picking up on Kasha's example of thinking about farmers, Gabbi, a recent video from Weathered, one of the channels, spoke to wet-dry cycles, and where some areas may have drought now, but the flood risk is going to change in the future. And a significant part of that narrative looked at farmers, who arguably the original citizen scientists, perhaps, and they have to lean into uncertainty every day. So how do you perhaps expand on that example, how you bring in talking about uncertainty and really letting the characters, as it were, of the story do that for you?
Yeah, absolutely. So across the network of PBS Digital Studios, we have the pleasure of working with a range of different storytellers, whether they are SciCommers or production companies, filmmakers, PBS member stations, and that comes with a range of experiences, which is really wonderful because it leads to diverse storytelling, right? A lot of different perspectives and ways of telling story. And one of the things that our creators sometimes struggle with is we're working in 10 to 12 minutes, right? We got to wrap things up in a nice bow and get the viewer on their way, and we have to keep them engaged for those 12 minutes. So one of the things that sometimes creators struggle with is we have to wrap this up in a really nice bow, and there has to be a solution, and there can't be any gray area. And our audience is actually very sophisticated, and I think that a lot of audiences online are sophisticated nowadays where they want the nuance. And so that's what we sort of tell the creators is lean into that nuance. It doesn't have to be a yes or a no or a good or a bad. Tell them why scientists don't know or why people are unsure, or show both sides of, of the argument or the complications that would come from this potential solution, right? So we really try to lean into the nuance and just be very transparent about, it goes back to the authenticity about what we know, what we don't know, what we're not sure of, what we are working on currently, and it gives our audience a lot more trust in us, I think, to not just oversimplify things, because that's when you really risk into potentially being incorrect by oversimplifying.
Interesting. So trust is so very important. Kasha, I wonder, in the work that you do, when you're talking about, say, peer-reviewed science, there are some members of an audience whose perception might be, well, you said one thing and now you're saying a different thing, and so how do I trust you? Because you don't seem to know what's going on. How do you communicate science for an audience that's charged in that way?
Sure. I agree with Gabbi that it's kind of embedded in the word when you say journalist. So before this job, I used to do Office of Communications. I was at NASA, and the jobs are very different because when you're a journalist, your job is when you get a peer-reviewed study, you write the findings and you also get outside comment. You put the caveats of the study. It's what Gabbi's saying about making sure that you're very transparent. So the job is a little different than like when I was a public affairs officer, because there your job is to promote the research. I would say that when you get at the Washington Post, the readers that come there, you have some people who are a little heated about things. But when you go into the comment section, people do understand the process of science, and it is giving the historical context. So, for example, Darcy, you mentioned that I wrote an article about the contributors to sea level rise, and one thing that might be a bigger contribution than what we previously thought is drying of water bodies on land. So previously it was a lot of glaciers, ice sheet melt, things like that. So it's kind of interesting because when you look at progression of time, okay, we've always heard glaciers are like number one, big source of sea level rise. Well, that's not always going to be the case as we go into the future because now our glaciers are dying. So that's going to empty, and then other sources are going to overcome it. So it's also talking about showing that we are Earth, we are changing in time, and this is just how science goes. I will say that I also write peer-reviewed studies on things that aren't climate change, like the origin of life. Like yesterday, I just wrote something about how water first appeared on Earth. And the popular theory is that asteroids came and brought some stuff perhaps by chance. And now some scientists are saying, well, we actually think that Earth might have had the ingredients for water as it was being formed. And it's funny because that is also kind of controversial, but just because of the nature of what it is, it doesn't get as heated when you say climate change, stuff like that. So the controversies are everywhere in all types of science, but when you deal with it in like climate change, you do have to be a little more particular, and also making sure you don't give the negative or the opposing voice more strength than it actually is appropriate for the studies.
Well, that's great. Thank you, Kasha. And so, Tom, trained in weather forecasting, and you once told me that one of the hardest things to do is predict snowfall. Like, for example, is it going to snow in Vermont on April 16th? So given that we live every day with the uncertainty of weather, how do you use that human experience to talk about what's unpredictable, uncertain in something like climate?
Yeah, sure. So we're all risk calculators. We talk about uncertainty. Really, we make decisions based upon uncertainty all the time. We determine how much risk is going to be. If I say there's a 30% chance of rain tomorrow, you can decide whether you're going to bring an umbrella or not. If I say there's a 30% chance of you crossing a street and getting hit by a car, you're probably not going to cross the street, right? There's different levels of this. And uncertainty often isn't your friend. Now, who here has been annoyed by a weather forecast before that said something or didn't say something, right? Have you then stopped and just forbade ever looking at a weather forecast ever again? Right, no. You can understand there's still value in that. Because you'd much rather still have the forecast than to have nothing. Because nothing is pure uncertainty. You have no idea what's going to happen. So often we talk about uncertainty, it gets talked about in the way being like, well, it might be better. For climate, there is a lot of uncertainty where things could be very much worse. And uncertainty is not our friend. As a scientist, we're trying to minimize the uncertainty as best we can. So this idea of talking about uncertainty, I mean, we all like to make decisions based upon the best available information, right? We don't like to just make decisions willy-nilly. And the idea here with uncertainty, I like to talk about this through the lens of just how we go about our day. And about what we are certain about, what we are not certain about. And this idea being that, one, we need to keep researching these things to minimize the uncertainty. But two, this idea of uncertainty is not your friend. It is something that makes us much more dangerous as we go into the unknown. And again, and I usually use the lens of a weather forecast because that's an easy thing that everyone has experienced before. And I always say, if you have a climate piñata and you smack a climate piñata, a bunch of weather falls out, right? So that's your first kind of foot into the climate world, because that's all it really is. So it's taking basically experiences that people have every single day, and then relating that to climate, and also explaining that nuance, which I think is incredibly important.
It's all about precipitation with you.
It's all about, I love clouds. What can I say?
All right, so I'd like to ask now, we have one of our students from Rutgers or Donny who would like to ask a question. Having been born at a young age myself, I remember how important it is to ask those who came before you to think about science communication. So, in the last few minutes we have, I can barely see. There you are.
It's on? Oh, wow. Okay.
Yes, you are on.
Cool. Well, when I was thinking, I mean, you're all addressing very contentious topics, and I think part of the issue with contentious topics is that because they're contentious, they're harder. Like the evidence itself isn't agreed upon. People don't come to them from the same premises. So you've worked at places like NASA, NOAA, places where I think some groups will dismiss any evidence that comes from, and where some groups will say, oh, those institutions have an agenda, and so they'll not be willing to listen to you if they think you're coming with an agenda. And so my question is, how do you address a contentious topic without appealing to authority, to a company or an organization that obviously has some goal in mind, something that it's inherently interested in.
Thank you. So in a sentence or two, Gabbi, how do you speak to science without deferring to authority?
Yeah. I think PBS is very lucky to be the most trusted media organization for 30 years in a row. We're here to serve the American people, and that is our goal. So one thing that we try to do in our science communication is really broaden who is a scientist. You know, a high schooler who's studying bugs in their backyard. We had a really great quote from the fire chief in our Weathered LA Fires special, and he said something along the lines of, I don't really care why you think this is happening or not, but it's happening. Fires are getting worse. And so I think expanding who is a scientist and who can be a scientist and who's doing science and who are the traditional knowledge bearers of this science, whether it's Western science or our indigenous science and knowledge bearers, really broadening that perspective and uplifting those voices so we come across as science is for everyone and everyone is doing science.
So which voices are involved? Tom?
I'm going to go back to something Gabbi mentioned earlier, authenticity. I know that when I'm talking to people, they may not basically accept what I say. They might completely reject me. And my goal often when I'm talking about climate change to an audience that comes up to me is that my goal is not to convince them, because in the end they have to convince themselves. My goal is for them to see me as a human being at the end of it. Is so that they can imagine like, oh, I can get a drink with that guy. Oh, he reminds me of a friend of mine. He reminds me of my cousin, whatever it may be. And that's often my goal. It goes into authenticity. Because I feel like once contentious topics and easily kind of you lose the humanity in all of it. So my goal oftentimes, if I can't convince you, is at least for them to connect with them at a level on something. So they see me as another person. And that usually is kind of the first step to having continued conversations. Because oftentimes these things, we think of them as one-offs, but it's a journey sometimes to having people understand things.
Thank you. And Kasha?
I agree with both of everything that you guys both said, but I would like to point out two things. One, I think there is climate research on this. The Climate Communication School at Yale, they've done a lot of research on who the people are that deny climate change. And there's a spectrum, right? So just because they're the loudest voice doesn't mean that they are the majority. You know, we hear about a lot of contentious, like, oh, these people are really, really against it. You're never going to be able to convince them. Those actually aren't the people you're trying to reach out to. There's a lot of people in the middle that can be swayed from one side to another, and those are the people who are rational thinking. Those are the people open to things, and those are the people that we're trying to communicate to. So that's one. Two is, the facts, I think, and making it an emotional experience, getting it to them on a personal level does speak to it. I mean, the Washington Post, yes, we do have certain audiences that come to us. We know who our audience is, and we try and expand that. But a good example is a few years ago, we had one of our reporters win the Pulitzer Prize for, she wrote this beautiful piece. It's not climate change, but it's equally controversial, about this young couple who wanted to get an abortion but couldn't, and kind of showed the life that they had. And when she won that Pulitzer Prize, like when they were doing the speeches and stuff, Ted Cruz was like, can you believe this? The Washington Post wrote an article against abortion. And that's not really what it was. It was just explaining the facts. But the fact that you can have these people from wildly different political views or backgrounds read the same story and come away with different things and see the different perspectives. I think that's what it is, and that encapsulates being authentic. It encapsulates showing the transparency and just meeting people where they are.
Much to talk about at this very summit. Thank you all very much, and I look forward to hearing everyone's conversations as we continue. Thank you.
All right, thank you, Darcy, but before you leave, right? We have some serious thank yous here. Thank you to PBS for what you do, and good luck in all that you do. Thank you, Tom and Noah, for what you've done, and I wish we all wish you well in your next career and for all you did there. And thank you for a little humor. You have a joke? You have a climate joke you'll do? Is there a quick climate joke?
You can come see me at one of my shows.
We'll do that. Okay, thank you all very much. All right, so you're here to hear science and how science can bring us observable fact and manage the uncertainty of science, be authentic in storytelling. Okay, that can help us manage conflict. So can engineering, science and engineering, when we bring teams together to solve problems, when we see collaboration as a narrative. So we were very fortunate here. Dell Technologies came to us. Who has a laptop? Who owns a laptop? Okay, everybody. What happens when you get, what do you do when you're done with the laptop? Okay, what happens to all that plastic? What happens to all that stuff? So they came to our engineering team and they said, help us figure this out. How do we recycle and reuse more parts of that? So we have a short video capturing the work of the team, which included, embedded in the team, is a communicator. Take a look.
You have to clap in there. Oh, yeah. Yeah. Nailed it.
Should I start? Were you going to say the question?
You can just start answering the question.
My name is Lola. I'm a senior in systems engineering with a minor in sustainability.
My name is Patel. I'm a senior assistant engineer.
This project is not your ordinary capstone. It came with its own set of obstacles, especially working with a huge industry leader like Dell.
By increasing recycled content, we're going to avoid the stage of making something, using it, and disposing it. So it will be instead making something, using it, and then we reuse it again. So that kind of helps in avoiding using raw materials more, which helps us to have more natural resources and avoid more greenhouse gas emissions.
This project wouldn't have been possible without collaboration across the team.
Everyone coming together is why the project is being successful, and especially with sustainability, it's really important. It can't just be an engineer solving all the problems in this world.
At the end of the day, sustainability challenges can be intimidating to tackle, but I think it's important to make efforts, whether that be through everyday activities or projects like these.
It starts with the smallest steps and it grows bigger and bigger. Even though the project we're working on is really big right now, any small choices that you make also make a big difference.
So Professor Dano is our professor for this senior capstone project.
The professor that has helped us the most in this project is Professor Dano.
My name is Professor Dano. I'm the head instructor of the senior capstone course. It's an honor to work with Dell and with the students on this capstone. I mean, sustainability is something that has to be performed at a much higher rate by everyone to really get the environment where it needs to be. This project is so extraordinary because it really touches on all aspects of a grand challenge being sustainability. It takes engineering, it takes the social sciences, it takes communications to get the word out. It takes understanding of politics, which all has to come together to help the environment. It also allows the students to really learn up on what they, or anyone else for that matter, can do to understand the environment and then figure out a course of action to make it better. The challenge has been exciting. I'm learning as I go. I learn with the students and the students learn with me, and it's been a great adventure.
Thank you, guys.
Thank you.
Okay. Thank you both.
How's that? Professor Dano, would you stand? And the team. Is your team with you? Owen cut the video, so thanks, Owen. So telling stories of people coming together, right, across disciplines to solve a problem. That's collaboration. That's a narrative of work and cooperation to solve a problem. And that's a very important way. And one of the things at Planet Forward we want to do, right? Inspiring stories to move the planet forward. What are the ideas, the inventions? That's a frame that we call it in storytelling, and something that can address the conflict directly.